Nie ma znaczenia, że nie namaczasz i nie płuczesz naczyń. Krótki cykl też nie ma znaczenia. To, co naprawdę ma znaczenie, to nowy cud fery w 30 minut.
Dzięki połączonej mocy 5 żeli czyszczących, nowy Fairy 30-Minute Miracle radzi sobie nawet z uporczywymi resztkami jedzenia. Co za czystość! Nowy Fairy 30-Minute Miracle, nasz numer 1 w usuwaniu uporczywych resztek jedzenia.
Lubella. Trzymamy paluszki. Za og...
Two weeks ago, Google quietly published a paper that most people scrolled past. It described a new AI model called Mogen that generates synthetic neurons.
This game of Pong that you're watching right now is being played by a bunch of brain cells in a dish.
Not neurons inspired by biology, not neurons as a metaphor, actual machine-made replicas of brain cells built from scratch, statistically accurate enough that other AI systems use them as stand-ins for the real thing. And Google is using these synthetic neurons to train AI to decode the real brain faster. Yes, such as 16 years of painstaking manual work. 300 modest. And separately, Google research mapped the complete brain and central nervous system of a larval zebrafish. Every neuron. All 70,000 of them. Tracked in real time as the fish responded to stimuli projected around it. Then, Using AI, researchers at HHMI Genelia built a simulation of the fruit fly's visual system from its connectome alone. No measurements of actual neural activity required, just the wiring diagram plus knowledge of the circuit's goal, detecting motion. Everything else, the AI inferred. The simulation accurately predicted the behavior of 64 neuron types and reproduced the results of more than 24 experimental studies conducted over the past 20 years. Let that land. An AI looked at a wiring diagram, figured out what the circuit was supposed to do, and predicted how every neuron in that circuit would behave, matching 2 decades of experimental research it had never seen. The researchers called this bridging the gap between the static structure of the connectome and the dynamics of real-life computation. The question they asked next was, can this scale to a mouse? And after a mouse, to something larger? Here is where the story stops being about neuroscience and starts